Okay, let's look into another type of line clipping algorithm, which is LIANG BARKSY line clipping algorithm. Okay, in previous line clipping algorithm, we learned about Cohen-Sutherland line clipping algorithm, but basically that Cohen-Sutherland is only good for the small and large window, and it also provide a poor worst case performance, and sometimes it also computes many unnecessary intersection. So that's why they come out with one more algorithm for line clipping, namely Liang Barsky algorithm. So let's learn about what is Liang Barsky algorithm. Okay guys, in this lecture, we're gonna learn about the Liang Barsky line clipping algorithm. Okay, before this, we learn about the Cohen-Sutherland line clipping algorithm. In this algorithm, in this Liang Barsky line clipping algorithm, it's used the same concept with the Cohen-Sutherland, but the approach are different. Okay, so let us learn about this algorithm first. Okay, for this algorithm, what we need to understand first is that initially we will need to read the two endpoint of the line. Okay, read two endpoint of the line. Let's say, for example, we have P1 and P2. Okay, we have this line of P1 and P2. And as usual, P1 will have the coordinate of x1 and y1, and also P2 will have the x2, y2. Okay, this one is usually you will understand this easily, which is P1 and P2, and this P1 have x1 and y1, P2 we have x2 and y2. And then after that, we need to read two corners of the window. Okay, we need to read the value of the xw min, yw max, xw max, and also yw min. Okay, we need to read this clipping window of the corners. And then after that, we need to calculate the values of the parameters. Okay, we need to calculate the values of the parameters. So we involve two parameters here, which is the pk and qk. Okay, we have two parameters here that we need to calculate, which is pk and qk. And then k here, k here is just the number of 1, 2, 3, 4. Okay, so pk and qk is the parameters that we need to calculate, and then k is referred to the number 2, number 1, number 2, number 3, and number 4. And then what we need to calculate for the pk is that we have P1, P2, P3, P4, and then for Q also we have Q1, Q2, Q3, Q4. Okay, for parameters of P, what we need to calculate to calculate and remember is that P1 is equal to negative delta x, P2 equal to delta x, P3 is negative delta y, P4 is the delta y. And this delta x, delta y is you learned in the previous chapter already, which is in order to find delta x is x2 minus x1. To find the value of the delta y is y2 minus y1. Okay, in order to easy remember this one is that you can just remember like this. Okay, delta x, delta x, delta y, delta y. Okay, negative, positive, negative, positive. Okay, negative delta x, positive delta x, negative delta y, and also positive delta y. Okay, delta x, delta x, delta y, negative, positive, negative, positive. Okay, and then for the parameter of qk, okay, we have q1 equal to x1 minus xw min, q2 we have xw max minus x1, q3 we have y1 minus yw min, and then q4 yw max minus yw1. Okay, so you might not be understand well about this algorithm yet. We will see that in the example later on. Okay, this is the step number 3. Let's continue step number 4 in the next slide. Okay, in the next step that we need to do is that we have the condition to see from here, which is if the pk is equal to 0. Okay, pk is the thing that you have calculated before in the previous step. If any value of the pk is equal to 0, it shows that the line is parallel to that boundaries. And if the qk that you have calculated before in step number 3 is less than 0, okay, any value from this qk is less than 0, it shows that the line is completely outside. Okay, so this is just the condition. And then the next step is that we have to perform initialization. Okay, we need to initialize t1 is equal to 0, and then t2 is equal to 1. Okay, this one is that we just need to initialize T1 and T2 only. Okay, initialization, T1 equal to 0, T2 equal to 1. Okay, and the next step we need to calculate. Okay, we need to calculate the QK by PK. Okay, QK divide with the PK. QK and PK is you already calculate it in the step number 3. So just use that value to calculate this QK and PK for all the PK, which is PK, P1, P2, P3, P4, and also Q1, Q2, Q3, Q4. Okay, you need to calculate of these 4 points. And then after we get this, we will divide this QK and PK into the one that is less than 0 and also the one that is greater than 0. Okay, so we need to calculate QK divide by PK. For PK that is less than 0, we need to assign the maximum value out of them as T1. And also we need to calculate the QK and PK for the PK that is greater than 0. And then this one we need to assign the minimum value out of them as T2. Okay, so you might not understand this well yet just now. It's okay because you will get that better, clearer or better understanding of this algorithm by using example later on in the next slide. Okay, after that, after you get this T1 and T2 from this step number 7 and 8 here, okay, if this condition, if T1 less than T2, okay, T1 is less than T2, we will need to calculate the endpoint of the clip line, okay, by using this 4 formula, and then you will get 4 point. Okay, from this 4 formula, you will get 4 point. X1 dash, Y1 dash, X2 dash, and Y2 dash. You will get this 4 point. And then you need to stop and repeat for another line if exists. Okay, if there are other lines, so we need to repeat it. If no, so we just stop this algorithm. So let's look into the example in the next slide. Okay, let's look into this problem of LIANG BARKSY line clipping algorithm. So you are given this problem with the window of 4 corners, which is consists of A, B, C, and D. Okay, consists of A, B, C, and D corner with the each of it have their own coordinate. And also you will see the two line here, line segment here of P1 and P2, which is passing through this clipping window with this coordinate as well of the P1 and P2. So based on the algorithm that we have learned in the previous slide, the first step that we need to do is we need to read the coordinate of these two endpoints, which is P1 and P2. So first, the P1 coordinate is the 10, 30, and then this one is representing X1 and Y1. Okay, X1 is equal to 10, Y1 is equal to 30. Okay, and then read the line of P2. Okay, P2 coordinate of P2 from this figure is the 80 and 90. Okay, the coordinate of 80 and 90. So 80 and 90 here is representing the X2 and Y2. Okay, X2 equal to 80 and then Y2 is the 90. Okay, so this is the first step. We go to the second step. The second step is asking us to read the corner of this XW mean, YW mean, XW max, and YW max. Okay, so we read this from this figure, or also can be from this window coordinate as well. But for better understanding, let's look into this figure. So for XW mean value is equal to, okay, XW minimum is here, so is 20. So we just list down this information here. XW mean equal to 20. For YW mean, okay, YW mean is the 20 as well. Okay, YW mean is 20 here, YW mean. And then XW max, okay, XW max is 90. Okay, here is a XW max is 90. And then YW maximum is 70. Okay, YW maximum is 70. So you get all the information here, XW mean, YW mean, XW max, YW max. Okay, so let's see the next step in the next slide. Okay, next let us calculate delta x and delta y. Okay, delta x is nothing else is the x2 minus x1. Delta y is nothing, it's just y2 minus y1. Okay, so for x2 is 80 minus with the x1 which is 10, so you get 70 for delta x. And then delta y is the y2 minus y1. Okay, y2 is 90 minus with the y1 30, you will get 60. Okay, so you got delta x here and then delta y. And then what you need to do next is that you need to calculate the P1, P2, P3, P4, and also Q1, Q2, Q3, and Q4. Okay, and then this formula is we have discussed before in the algorithm. So let's find out P1. Okay, P1 is nothing else, it's just negative delta x. Okay, negative delta x is the negative 70. Okay, delta x is 70, so just put negative. Okay, negative 70. P2 is nothing else, is the positive delta x, which is 70. P3 is negative delta y. Okay, negative delta y is negative 60. And then P4 is delta y. Okay, delta y is 60. Okay, so you get this value. And then we calculate the Q1, Q2, Q3, and Q4. Okay, Q1 is x1 minus xw min. Okay, x1 is the 10. Okay, x1 is 10 from the previous slide. Okay, 10 minus xw min, which is 20. You get negative 10. And then you calculate for Q2 using this formula, xw max minus x1. Xw max is 90 minus with the x1 which is 10, you get 80. And then Q3 is using your y1 value minus with yw min, which is 30 minus 20, you get 10. And then Q4 is yw max minus y1, okay, which is 70 minus 30, you will get 40. Okay, all of this formula is we have discussed in the previous slide in the algorithm, so you can look back. And then after we get calculate this P1 and all the PK and then QK in this parameter, okay, what you need to do next is that we have to check the condition if there any value of PK here, okay, is there any value of this PK here is equal to 0. Okay, so you look into this answer, is there any pk value that's equal to 0? So there is no 0 value inside this pk, so it shows that is inside the clipping window. Okay, and then you check the condition on the qk plot, qk part over here. Okay, qk, you check whether is there any value of this qk there is less than 0. Okay, this part. Okay, you check whether this qk, any qk value here is less than 0. Okay, so this one is more than 0, more than 0, more than 0, but this one is less than 0 because it's got negative 10. So it shows that if there is any qk that is less than 0, it shows that is partially inside. Okay, so let's look into the next slide. Okay, let us initialize the T1 is equal to 0 and also T2 equal to 1. And then after you have calculated the PK and also QK in the previous slide, we need to separate this into two parts. Okay, you can see on my on this slide there is two part here, one on the left and also one on the right side here. So these two parts need to be divided into negative and also positive value based on the pk that we have calculated in step number 3. Okay, in the previous slide we have calculated the p1, p2, p3, p4 and also q1, q2, q3 and q4. Okay, so we separate into these two parts, either your pk is less than 0 or the part of pk is greater than 0. Okay, so all the pk and also pk that is having the negative value from the step number 3, so you list it down under this part, which is you can see in the previous slide that p1 and p3 have the negative value, so that's why it's on this side. Okay, p1 and p3 having the negative value. And then for the P2 and P4 is have the positive value. That's why it's on this side. Okay, on the PK is greater than 0. It's because it have a positive value. So after you divided this into two parts and identify which pk will have positive and negative value, we need to calculate the this parameter using this formula, which is qk divided by pk for the p1. Okay, k here is representing the number of this one. Okay, so it means that q1, okay, divide p1. Okay, q1 is negative 10, okay, divide p1, which is negative 70. So you get the answer 0.142. And then you also need to calculate for this p3, which is using your q3 divide p3. Okay, q3 divide p3, which is q3 equal to 10 divide negative 60, which is p3. So you get negative 0.166. So for this case of this pk less than 0, okay, this side for this part, for pk less than 0, we need to choose the greater or maximum value from this choice. Okay, so you look at this, whether this 0.142 or negative 0.166, which one is greater? Which one have a maximum value for these two choice or two option here? So for this, we need to take this 0.142 as our T1 because it have a greater value or maximum value compared to this one. So take the greater value for this side as a T1. And then we look into the pk is greater than 0. So here you have p2 and p4. Also, you need to calculate the qk divide pk. So for this p2, using your q2 value minus divide p2, which is 70, you get 1.142. And also for p4, using your q4 divide p4, your q4 is 40, your p4 is 60, so you get 0.66. Okay, for this part, for the pk greater than 0, we need to choose the lower or minimum value. Okay, so you look into these two options here, which value that is minimum or lower than the other. Okay, from this, either this 1.142 or 0.66, which one is lower or minimum value? So 0.66 have a minimum value. So for this, we need to choose 0.66 as a T2. Okay, so now we have the value of T1 and also the value of T2. So let's see what happened in the next slide. Okay, after we have chosen our T1 and T2 in the previous slide, so we can use that information or that value into this four formula that we have discussed in the algorithm before. Okay, there are four formula here. Okay, so let's look into the first one. Okay, calculate using this formula x1 dash, okay, x1 dash equal to x1 plus T1. Okay, T1 is from the previous slide that we have calculated, multiply with the delta x. Okay, so we get that 10. Okay, x1 is 10 plus with the t1 is 0.142 and then multiply with the delta x, which is 70. So you get 19.9. So you can round it into 20. Okay, you can round this one. And then we calculate for y1 dash. Okay, y1 dash is using this formula, y1 plus t1 multiply with the delta y. Okay, so we get 30, which is y1, plus with the t1, which is 0.142, and then delta y is the 60. So you get 38.5. You can round it into 39. Okay, so let's look into this the endpoint of one more point on the end line here. X2 dash equal to x1 plus t2, okay, multiply with the delta x. So you get x1 is 10, okay, plus with the t2, okay, your t2 is 0.66, and then multiply with the delta x, which is 70. So you get 56.2. So you can round it. So you get 56 for the x2 dash. And then we calculate the y2 dash here using this formula, y1 plus t2 multiply with the delta y. So your y1 is 30. You plus with your t2, which is 0.66, multiply with the delta y, which is 60. Okay, so you get 69.6. So you can round it. You get 70 for your y2 dash. So based on this calculation using this formula, you will get this 4 points for your clipping window. Okay, for this line, so you get 20 for your x1 dash, and also y1 dash is 39. Okay, 20 and 39 for this point, and then you will get for your x2 dash here is 56 comma with the 70, which is your y2 dash. Okay, so this is the line that is lie inside the clipping window. Okay, the one that is outside is will be clip. Okay, so I hope you understand this Liang Barsky line clipping algorithm using this formula. Thank you.